我先来 share 一下 screen。那我们开始。
好的，好的，那就开始了。
首先，先感谢小亨利，然后来volunteer 来参加这个 mock interview。然后这个题不见得是跟你们的那个 topic 完全相关啊，是一个我真实遇到的一个面试题，然后我觉得还不错。然后我们今天来试一下。Okay, let's jump right in. So today's question we're trying to solve together is a question about lighthouse. So you'll be given a two-dimensional grid. It's n by n two-dimensional grid, and on each grid you you may have a lighthouse on each position in the grid. So we first will give you an n that represents the size of this grid, and then we have a array, like a two-dimensional array, that has like the coordinates, a bunch of coordinates. At each of the coordinates, you have a lighthouse installed in this cell of the grid. So, for example, I can have a lighthouse installed here. I can also have a lighthouse installed here. So whenever we have a lighthouse in the cell, you're going to illuminate its current row and its current column and its diagonal directions. So for example, because we have a lighthouse here, so its row will be illuminated. So this row will be illuminated, and its current column will also be illuminated. So for this one, it's the same. So its column is going to be illuminated, its row is going to be illuminated. And also, we're going to illuminate its diagonal direction. So for both lighthouse installed here at those positions, its diagonal position is going to be illuminated. So we will give you another array of coordinates, which each element in that array represents a query. So I can ask you, like, is cell 1, 1 illuminated? The answer you're going to return to me, it's either 1 or 0. 1 represents the cell I'm requesting is illuminated, and 0 means it's not illuminated. And whenever we answer a query, after you return the results, you're also going to going to remove all the lighthouse installed in all its 8 adjacent cells, including the query the points itself. So if I'm querying this point 1, 1, is this cell illuminated? So you're going to return the answer 1. And then after that, you're going to turn off itself and remove all the lighthouses in its 8 adjacent cells. So all the lighthouses in this area will be turned off. So in this case, this one is turned on, so we're going to turn it off. Of course, after it's turned off, then all those illuminated cells are going to be no longer illuminated. So if I remove the lighthouse here, then because this lighthouse still exists, then this diagonal direction will still be illuminated, and this column and this row will be still be illuminated, but those cells are no longer illuminated. So that's the problem description. Is that clear? Do you have any questions?
Yeah, I think mostly the question's clear, but I do have a couple questions to clarify first.
Mm-hmm.
So first of all, given integer n, which means the size of the grids, does it mean the grids is always in a square shape?
Yes, it's always squared grid.
So it's going to be n by n squared.
Yes, it's always n by n squared.
And is it guaranteed that there always has at least one grid in a square?
What do you mean always one grid? There's always one grid.
Which means n cannot be 0. This is basically an integer larger than 0.
Yes. N is always greater than or equals to 1.
Okay, and
So you have n and then a two-dimensional array with all the coordinates that are all the initial lamps or lighthouses are installed, and then you have an array of queries.
okay, and
Mhm.
all the inputs are in integer format.
Right. Yes.
Okay. Let me just write down the clarifications here. You just create a solution class inside the solution class.
Oh, you can just remove this one.
Okay, I think I get a question.
Mhm.
So the lamps means the lighthouses, and it will illuminate some of the grays. And we need to find for each query return is either the 0 or 1. 1 means it is illuminated, and 0 means it's not.
Yeah. So the queries could be something like this. And then you can just return a array. Maybe it's like for the first query 1, it may be illuminated, and the second one may not be. So you return 0. So you just return an array of integer like this.
And during the process of processing these queries, it is possible some of the lamps are removed so that the queries afterwards don't have a lamp or it's not illuminated anymore.
You return like after you answer the query, you just remove the queried points. Like the lamp, if there's a lamp at the query point, then you remove that lamp, and all lamps within like the 8 adjacent cells.
Okay, and we're going to process the queries in the order as in the input array.
Right. Yes.
Okay,
So
I think.
yeah, if there's a lamp here, and if there's a lamp here, and this is the query point, then you remove the lamp here and all the 8 adjacent cells if they have a lamp. So both lamps will be turned off, like will be removed.
Okay, I think I get the basic idea. So the way I'm going to do this, I'm just coming up with the easiest, most straightforward solution for now. Is to, for each query, we will iterate all the lamps that exist right now.
Yeah.
And for each lamp, we check if this query is on the path of this illumination.
Okay.
And if we're going to return 1 and then remove the lamp and then keep processing the next query.
So it'll be the simulation.
Yeah.
Okay. Yeah, sounds good.
Okay, I'm going to write a code for that one. So since we're going to, also another question to clarify, is it possible that in the input, there are, especially the lamps, there are duplicate lamps on the same grid?
Yes, there could be.
So that doesn't
in this array, there could be like, I can have 1,000 lamps all like with the coordinate 0, 0. That's also a valid input.
But does it mean there are 1,000 lamps on the grid, or it's just
no?
One?
There could be only one lamp within each grid, within each cell in the grid.
Okay, so once I remove the lamp on this specific grid, there shouldn't be any lamp anymore.
Yes.
Okay, got it. So if that's the case, I probably will create a step first. To store all the lamps.
Okay.
Actually think about this. because in the array actually are different, even though the values are the same. Probably
Mhm.
also a hash function here to make sure that the same, the two different coordinates with the same x and y value have the same hash value, which basically means if the x and y are same, then it's the same set, so that it will only be one instance of the same.
Okay,
value.
yeah, I get you. So this is duplicating the input.
Yeah.
Okay.
Let me do that part later. And for each query, so what I'm going to do here is to check if it's on the path of any of the lamp.
Okay.
One way to do that is another function. So there could be three different situations. First, the query is on the row of the lamp. And we find it's illuminated,
Yeah.
or it's on the column of the lamp. It's also easy to check. The third situation is to check if it's on the diagonal direction.
So there are two diagonal direction. So it could be this
exactly.
direction.
So
Yeah, okay.
to do that, it's basically saying that the horizontal and vertical distance between the query and lamp should be the same.
You mean the row or row index and column index?
It's the row and column index difference. The absolute value of the row and column difference should be the same, which means the horizontal distance and also the vertical distance. If that's the same, then it should basically means that it's on the illuminated path. Either way, it's one of the direction.
Okay, could you code that?
Okay, sure. So we're basically return.
So this is for the query is on the same row as same column.
Yes.
Okay.
And the next thing is to check if the distance of the row and column is the same. Yep.
Okay.
So for example, we have if we have lamp house at 1, basically if this is the query, then the horizontal distance between these two is 1, but the vertical distance between these two is 2, which is not the same. So it is not on the correct direction.
Okay. Yeah.
But if it is, for example, it's like here or here, then the horizontal and vertical distance, they are the same. So it means this is on the correct direction. Now here we check the path with the query and lamp. If we find a path here, then what we're going to do is to add 1 to the result. Here, let me use a list. And the next thing we want to do is to remove the lamp from the lamp set. Now here's another problem. While you are looping a set, you cannot make modification to the set. Otherwise, this is going to have compile error.
Okay.
So what we can do here is to use another set, which is called remove lamp. And then when we're iterating the lamps, we check if it's removed first. If it's removed, then we're not gonna check the lamp.
Okay. So you said why you cannot modify the lamp set? Can you repeat that again?
Yeah, because while you are iterating through a set.
Oh, okay. So you okay.
We cannot remove things from the set. Otherwise, Java will say a compile error.
Okay.
Otherwise, it means we didn't find a path. It's either the lamp is already removed, or we cannot find a path for that. But actually, for this query, we need to decide that after all of them are iterated. So after all of the lamps are iterated, we need to see if it's already find a proper lamp. That we can either use a flag or probably some other solution. But right now, let me try using flag here. If for all of lamp we didn't find, oh, should be outside this for the. For all of the lamps we didn't find a solution, then we are gonna add a 0.
Okay.
And the result will be an array.
Okay. Could you write a test case for it?
Sure. I haven't read the hash function here. I think for Java. I don't really remember how to add a hash function to a hash set right now. But another way I can do this is.
So what could be a quick workaround for this?
We can store all of the coordinates as single number. So change this to. Here's another question. Is n could be an integer, but it's possible the number of the grades is bigger than the max value of the integer.
Let's assume that the grid can no longer cannot overflow integer range.
Okay, then let's use integer. Since we're given n as the size of the square, then we can basically, this is row number, multiply n plus the column number. Here we basically assign an ID for each of the grade. Yep.
Are you sure like if you do this computation, it still won't overflow integer range? If I give you like integer max, can you still multiply like n equals like, for example, 10 to the power of 9?
But you said the number of grades cannot overflow integer, or only n cannot overflow integer?
N cannot.
Oh, okay. I thought you mean the number of grades cannot overflow integer. Yeah, if that's the case, then we need to use a bigger size to store all the numbers of them.
Okay.
Here we need to make coordinates change here. Actually, let me use long just for sake. So from the long number, we recover the coordinates of the lamp. So we can make this a little bit simpler.
Okay. All right, before we move on, could you try to walk me through this case? If n equals 10, could you help me calculate your hash value for these two coordinates?
Sure. Looks like it's going to be the same. So probably using some modification on the calculation of the coordinates. Oh, actually, it cannot be a valid case because n is 10, then you cannot be 10. You don't want to be 9 if you index from 0.
Ah, okay, yeah, you're right.
Okay, let me try to run some test case.
Mm-hmm.
So just a super easy, simple test case can be the size of the lamp array or the size of the Curie array is 0. So there are either no lamps or no Curie.
Okay. So could you just maybe you can just list a few test cases you want to, without needing to just write them down. Could you just
Sure. I can just
list a few cases?
Sure. So instead of writing down code, you want me to talk you through the test cases?
For them, you can just like type here like test cases. Like you can just
right.
enumerate some cases you want to cover.
Oh, of course. So let me try a couple edge cases right now.
Mm-hmm.
No lamps. 0 lamp house. So in this case, for example, there's going to be no lamp house here. And if there's no lamp house, then we shouldn't, all the Curies should return 0. So it's going to be a list of 0. The size of the list will be the same as the size of Curies.
Okay.
Yeah, so when the size of the lamps is 0, then basically the lamp set is going to be an empty set. So when we are iterating the Curies, there will be no lamp for every Curie, and the found will always be false. Oh, actually, yeah, one thing. And then we're adding 0 at result for each of the Curie, and the result will be a list of zeros.
Okay.
So if there's no Curie in the input, then we're basically return an empty array. So the iteration of the Curie will not do anything because there's no Curie, and result is an empty list, so it's just gonna return an empty array.
Mm-hmm.
3 can be a really simple, successful path that we test. For example, there is only one lamp, and we have one Curie, and the Curie is right on the spot of the illumination. For example, we can try this thing. Let's try first, it's on the same row. So if they're on the same row, then we're basically checking if they're equal on the row number, which is X. Here, both of the row index is 1 for the Curie and the lamp. So I think it should gonna return true when we check the path.
Okay.
Yeah. Then we're gonna add the result of this lamp to the removed set, and also add 1 as a result and mark the found as true. Mm-hmm. And after the iteration is finished, this won't be executed. And then since we only have 1 lamp and 1 Curie, that's all of the loops. And then we're gonna return an array of 1 in it.
Oh. So so for each query in your current code, you're gonna iterate on the all the existing list of lamps to check for each lamp. Just to basically just simulate the process. Like, could you do? Is there anything that we can do to make it better, especially to improve the performance? If, for example, we have a huge number of lamps and it's going to be huge.
Yeah, sure. Let me just think about it. I think, yeah.
Mm-hmm. Yeah, go ahead.
I think what we can do first is to iterate all of the lamps and then mark the illuminated areas. And then for each query, we check if the illuminated area is, if the query grid is already illuminated. If it is, we're gonna remove all of the, well, actually, I think I misunderstood the question a little bit. We're only going to remove the lamps on its neighbor grids, right?
Yeah.
Oh, actually, so here I actually need to check if this lamp is in the neighbor grids.
Yeah.
By the neighbor grid. I thought this to illuminate, remove any of the lamp that's illuminated path.
Okay. Yeah. Because we're running out of time, let's like just assume you have that part. Like by adding this, you're already removing all the adjacent lamps within that like 8 adjacent cells. Like let's assume that part is done. Well, what else can we do to kind of optimize the performance of their code here?
Yeah, so like I said, we can mark the grids as if it's already illuminated or not. So by doing that, since for each lamp, it's going to illuminate all of the column, the same column, the same row. We probably can keep an array of Boolean values and then mark each, which stands for each column and each row, and then mark is as true if there is a lamp on this column or on this row.
But you're still like you're introducing an n by n array in this case. Just mark them.
No, not really.
Okay.
For now, not yet. So for now, we only need to mark rows and columns, each required an n-size array. But the problem is this doesn't really record the diagonal directions. To efficiently mark that, let me think about it.
So for each column and each row, are you just mark it as a Boolean value, whether it's illuminated?
We can use one array to like integer numbers, like using different integer values to stands for if it's only column is illuminated or both of the column and row is illuminated. But here, if we want to use 2 arrays, we can use the Boolean, I think.
Okay. So it's still like, so if I have like both those 2 cells are a lamp, and then you have a row vector and column vector, then the row vector will be like 0, 0, 0, 0, because they are not illuminated. But this column, this row actually, because they have 2 lamps, so you mark as 2 or what?
Yeah, so let's say right now I'm only thinking about row and columns right now. There should be another way for diagnosis.
So yeah, you can basically maintain a count of lamps on each row and each column, right?
Yeah, sure. I think I can do that too.
So how does that work if I maintain a count?
Yeah, so then for each lamp, we're adding 1 value for that row and that column. We're having like 2 arrays, 1 for row, 1 for column. Then we're adding basically 2 of the values to the 2 arrays. And for diagnosis,
so how do you, can you maintain something similar for the diagonal directions? Like the questions would be, given a coordinate x and y, how do you know which diagonal line you're going to fall into?
Sorry, I'm not refreshing the things you wrote here. Can I refresh the page?
What?
Are you writing something on the screen?
Oh, you cannot see my shared screen. Sorry. All right, let me copy it over here. So using your example here, above here. So this is lagging so much. So this is row 0, row 1, row 2. This is lagging so much on my side. So 0, 1, 2, 3. So given the cell with coordinate x and y, how do you know which diagonal line you're going to fall into?
Yeah, I think similarly for rows and columns, we can also keep arrays of diagonal directions too. In this case, we also need 2 more arrays of size n plus -1, I think that's it. So for example, if the size of the array is 4, then we're going to have 1, 2, 3, 4, 5, 6, 7.
2 times n minus 1. Okay.
Yeah, and let's say it's the first one, and because we also need to count the different direction this way, so we also need another array. And also for each coordinates x, y, we need to calculate the index of the grid in the 2 diagonal direction arrays.
Oh, yeah, how do we do that?
Let's see. We need to work this way. With the x, y, then let's see, we zero index from here and here. It's going to be, this is x plus, it's going to be, no, actually, let's start from here. It's going to be easier. 3, 4, it's going to be x plus.
Okay.
And the other way.
0 plus 0 will be 0, and then 1, 0, and 0, 1 on the same line. And then 2, 0, 1, 1, and 0, 2 are the same line.
Yeah. So
okay.
That's the array that starts from 0 index from the top left. So we need to count another one which starts from the top right. So the other one. The so it's basically the reverse index of y actually plus x. For example, basically same idea. We want this to be 0, 0. Then we're basically reversing the column index. Instead of this being n minus 1, this is being n minus 1, this is being 0. So instead of this being y, it's going to be n minus 1 minus n minus 1 minus y.
Yeah.
So for 4 of the arrays, then for each grid, we mark, we increment the number of the lamps in this array. And after this, for each query, we also check the 4 arrays. And if there is an lamp, which means the count value is larger than 0, then we remove all the lamps around it. And when we remove the lamps, we also need to check again the count arrays to make sure that we do a decreasing one for each of the lamp on the possible directions.
Okay. Yeah. Could you code that up?
Let me write a new one. Each lamp, we're going to have 4 arrays here. They'll be initialized as 0 values. So on the row, which is 0, we're going to have 1 lamp. Column. Actually, since we're gonna do the update of the arrays multiple times, let me just use another method to do this. For each query, we're going to check for the 4 arrays if there is lamp on it. I probably have some more. Yeah. And also to remove all of the adjacent lamps.
How would you do that? Also including the self.
Also including the self.
Yeah. Just turn off that light and its adjacent.
We can put the query on the lamp. Here we need to check if this is out of boundary. Let's extract this out as a
Okay. We're running out of time, but you're on the right track.
Okay.
We can wrap it up here. 好，那就是这个就是今天的这道题了。然后大家有什么 comment 和 question 吗？这个其实小亨利这个其实它最主要的一个题就是点就是说，怎么去用 cache 来去解决这样的一个需要就是比较 computationally intensive 的一个 problem。然后它的一般的轨迹就是说会先像小亨利这样说啊，我先 simulate 一下，然后搞一个 set 呀，或者是一个 map。然后有些人可能是会上来搞一个 two-dimensional array 啊，然后当然这个东西会 blow up memory。然后那好一点就是像他这样用一个 set，然后再 follow up 的，就是说怎么用一个 cache 的方式来去尽可能的缓存这样的一个东西，让它能够快速的去得到一个解。然后可能有一点 trap 的问题，就是它刚刚其实最开始已经 throw out 这个 question，就是说它可不可以重复定义一个 lamp 的 coordinate， 这个他也一开始也问到。然后可能最难的点在于，这个我不知道，我现在有点不太确定它对不对，应该是可能是 n 减 y 加 x， 可能没有这个减移，你可以去 verify 一下。然后
a 减 y 肯定是不行，因为 y 等于0的话就变成 n 了，n 就 out of boundary。
00啊 ，OK，yeah， 对，应该是 n 减1减 y， 对。这你可以 verify 一下，就是对这个基本上最主要的就是这个部分，就是你怎么去 calculate 去 cache diagonal direction， 然后这个就是实际上是一个纯算法的一个 trick。
然后我觉得我有几个地方没有做好的，还有就是你问 clarification question 之后，应该把确定下来的东西最好都写下来，因为我记得你一开始说的是 remove 8 neighbors。
我说我当时应该是说的是说我要说 turn itself off and its adjacency 8 cells if they have any lamps in there。
就是这个地方，我觉得clarification 的时候没有问清楚，就是还是有很多东西得问明白先。然后包括就是那个 all of integer integer max value 的那个问题也是。
这个你其实一开始没有问那个 n 到底会是什么样子的，然后我也就没有去提醒，因为我觉得说如果写出来的话，这个会是一个 follow up question，因为这个我可以去 stretch 说任意一个 n 或者是多大的这个这些。
我只问了 n， 但没有 n 到 n 方的那个可能性的 range 是多少？
对。然后这个 set 其实你当然可以这样算了，但是你其实也可以更简单，你就直接把它 convert 成 string 的 hash 也可以，就是比如说 x b x y， 然后你去 hash 那个 string 也是可以。
我一开始有想过，但是我觉得就也挺麻烦，你把它再还原成，就你给它还原成 coordinates 的时候，你还要做一个 parse， 然后你还要做一个 split， 通过逗号或者空格 split numbers。
对，然后还有可能再会问的，我就可能会想问，我每次都会愿意问，就不管是什么样的一个题，我每次都会最后如果有时间的话，愿意问 multi-threading， 就是 thread safety。假设说你的这个东西不是只有一个 thread， 可能有 multiple thread， 然后 with multiple clients 去 serve 一系列的 queries， 然后怎么能够保证它的每一个 query 能够不会 step on each other， 这个会是一个 follow up。然后这道题是lead code 上的1001，这是一道 hard 的题。但是我最开始没有刷到过这道题，然后我是面试的时候面到这道题了，然后后来我再去找，我发现原来是这样的一个题。然后挑出来的一个 point 是说，我觉得你可能很多时候面试的时候会遇到 hard 的题，但是我觉得这个 hard 的题并不是很 hard， 就是尤其是说对于 interviewer 来讲的话，就是经常给一些 hint， 实际上能够很快的把这个人放到一个 right direction 上，然后他能够很快的去弄出解。就我觉得这个其实是想说，我是想表达的就是说其实面试当中遇到 hard 的题并不是很可怕，然后多问问题，然后面试官会帮忙你去整理这个思路，然后其实你也是在这个情况下，这个是跟你自己在这个给你一道 hard 的题，然后你自己刷出来结果是不太一样的，因为他们会给到很多的 hint， 能够帮你快速的达到一个不错的一个解。就是这个样子。然后大家还有什么其他的 comment 和 question 的话，可以说一下。张忠宇果发了一个 What's the range of size of grid is？ 这就是那个 n，这个不是很，就是因为你其实说实话来讲的话，如果正常给到小亨利这个时间，然后他其实是这道题基本上已经写了80%-90%了，然后可能再有点时间问一些 follow up， 然后这个面试就 OK 了。
我觉得这个代码量还是就不算少的，我感觉
这个代码量虽然是比较大的，但是实际上你也不太需要把它完整的，就是其实写到这个程度就已经，我觉得对于我自己的公司里的面试来讲，就是已经 OK 了。
我感觉如果是 follow up 的话，如果有些地方能提前看出来，可以用一些这个你可以把它 stretch method，你可以提前写出来，然后不 implement， 就有一些比较 Travis 的东西，你可以简单略过，如果有时间的话再回去填。
OK。
小叶老师出题好狠。
但是我觉得你就做的很好啊，就是其实我在想我今天想了想，就是说搞一道什么题，然后我就想到了我自己面试遇到的题，然后我就觉得说，我今天才去查，后来发现是个 hard， 我一想那我觉得这个实际上，其实想向大家表达就是说，不要害怕在面试当中遇到 hard 的问题，都可以。如果这个面试官不是诚心为难你的话，你是可以做出来的，就是不要。就是我觉得这是一个帮助大家树立自信的一个面试，一个 mock interview。 好吧。好，感谢小亨利，然后感谢大家。